Okay, so we made a Treblista. And so how many times has this ever happened to you where your rubber band just snaps? And so here is the problem that we based off of. Things like bows or ballistas that are torsion powered, and basically things are being bent or stretched to provide power, and those have a large habit of breaking. And so we decided to make a non-torsion powered flingy thing to launch other things like darts. And so that could also be used to throw balls, dog treats, anything, as long as you can attach a shaft to it.
And so we've done some research on this in the past. For an Innovate project, we did a trebuchet, and so that's where some of our background information comes from. And so we researched a whole bunch of things to try to learn more about it. So we researched these things called Swiss arrows. We researched bows, ballistae, trebuchets, and human-powered means. There's this thing called an atlatl, which, you know those arms that you put a ball in and then it helps you throw them farther for your dog? Well, it's kind of like that, but for launching darts. And so we researched all of these things and found out that they all utilize things like levers, centrifugal force, and they use that to get greater distance and power out of the throw. And so we finally decided that what we would do is mostly like a trebuchet, but this throws darts. Trebuchets, they use a sling to throw a ball, but that hampers what you can use it for because you can only throw circular objects. So we decided to attach a track to it so that it could launch darts and other things like that. And so we went through a few ideas and just decided on a simple track. So you could load a dart or whatever you're firing, dog treats, into the track, and then it fires like a trebuchet or a catapult. Yeah, it just uses gravity on this weight, and that swings down, pulling the arm forward, and that launches things.
And so this is our prototyping process. So we started off by making the supports, and then from there we made the arm, and then put everything together, made a dart, and then at the very end we attached wheels to it to add efficiency and better throw, and we also added a counterweight to account for that and make it throw.
So now is a video of one of our tests.
Yes.
So as you can see, it fired and the basic idea worked, but it obviously didn't go very far either. And so we determined that that was down to a few main problems. So for one, our counterweight was not heavy enough for our projectile. Your counterweight is supposed to be 113 times heavier than your projectile, and ours was closer to 30 times as heavy, so it did not go very far. And also our counterweight didn't really fit within the constraints of the supports. It kind of jostled into them when going, as you can see. So it's just really jostly and inconsistent that way. And so there were a few other things. For example, we weren't able to utilize everything we learned. Like, we couldn't utilize centrifugal force because we didn't have enough time. But we planned that we could add a hinge for the track so that it would swing around as it goes and impart more force.
So what we could also do